A warm good evening to one and all present here. On behalf of the Coimbatore chapter of Computer Society of India, I welcome you all for the fortnightly webinar. And today the webinar is by an industry expert. And we are in an era where we look for solutions that are more real-time oriented. And that's a place where today's topic is going to fit in. So this session is about object-oriented programming simplified, a beginner's guide to software design, which is a need of the hour. So for this session, we have a excellent resource person, and I now invite Mr. R. Saravanakumar, Chairman CSI Coimbatore chapter, who is a renowned social entrepreneur and also a visiting professor at PhD College of Technology and former director, Cognizant Technology Solutions, to welcome the gathering. Sir.
Thank you. Thank you very much. Iniya Malai Vanakkam. Good evening, everyone. On behalf of the Computer Society of India Coimbatore chapter, it is my pleasure to welcome you all to this exciting webinar titled Object-Oriented Programming Simplified, a Beginner's Guide to Software Design. Our mission is to promote the advancement of computer science and technology and to provide a platform for professionals, academicians, and students to come together and share ideas. Today's webinar is a part of our efforts to achieve this mission. And we are happy to have Mr. Murugesh Viswanathan with us today to share his expertise on object-oriented programming. As we begin, I would like to express my gratitude to each and every one of you for taking time away from your busy schedule to join us. Tonight, our expert speaker, Mr. Selvaraj, will break down the fundamentals of OOP, object-oriented programming, making it easy to grasp and apply in your projects. You will take away a deep understanding of the core principles, including encapsulation, inheritance, polymorphism, and abstraction. You'll also learn how object-oriented programming enables scalable and maintainable software development, explore real-world applications in Java, Python, and C++, and also discover best practices and common pitfalls to avoid. Throughout this webinar, Mr. Selvaraj will share practical examples and case studies to inspire and kickstart your software design journey. By the end of the session, you will be equipped with the knowledge and skills to elevate your software design skills and take your projects to the next level. Now, without further ado, please join me in welcoming Mr. Selvaraj. Let's get started on this exciting journey into the world of software design. Thank you once again for joining us, and we look forward to a fantastic webinar. Over to our MOC.
Thank you, sir. Now it's time to know about our guest speaker, and I thank the Coimbatore chapter of CSI for giving me an opportunity to introduce the guest speaker. I myself, Dr. Maharasan KS, an MC member of this chapter, also a faculty at KG College of Arts and Science, Coimbatore, is here to introduce the guest speaker. Our guest speaker, Mr. Murugesh Viswanathan, is a postgraduate in computer science and also a postgraduate in higher education, having more than 2 decades of experience in teaching, administration, technical training. Basically, our resource person, he started his career as a teaching faculty in an institution, that is in a college, and subsequently, as a part of his career, he moved on to different levels, not only in India, but also in abroad. He is a international exposure resource person, having skills in the fundamentals of programming, the fundamentals of computing, and also a seasoned trainer in Java full stack and data structures, and also in all the other fundamental technologies and the emerging technologies. We are fortunate enough to have Mr. Murugesh Viswanathan as our resource person for today's session. So in today's session, Sir will be sharing his experience and expertise about what is this object-oriented concepts all about and how is it applicable for software design. Sir, once again, I welcome you to this webinar. Now it's time, sir. You can share your experience and expertise with us.
Okay. Thank you, CSI, for giving me this opportunity to deliver this wonderful topic, which was suggested by the chairman of CSI Coimbatore chapter. And now, because of that, I'm able to prepare a 1 hour webinar on the topic called Object-Oriented Programming Simplified, a beginner's guide to software design. Okay, can you all see the screen?
Sir, I have to stop my presentation, then yours will be visible. 1 minute, sir.
Okay, stop it.
Sir, please share your screen once again.
Okay. Let me do it. Now, can you see the screen?
Yes, sir, it's visible.
Thank you, sir. Thank you. Yeah. Audience, can you all see the screen? You can put a thumbs up. Very
Yes,
good.
sir.
Very, very good. Yeah. Thank you. Thank you so much, guys. Thank you so much. Wow, 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 wow. Okay.
Let us continue, please.
Yeah. So, see, this is this evening. I'm going to present you on the agenda for this evening is object-oriented programming. Basically, that is the object-oriented programming. What is an object? Basically, tell me what is an object. Let me ask the question and reply the answer. Okay. Object is something which whatever you see in your naked eyes, we see only objects. Okay, we see only in real time. We see only object in through our eyes. Okay, so the same terminology was tried, and they wanted to implement it in software system, in building software systems. Okay, so it is way back in 1980s or some time back. There was they created the first object-oriented programming language which was created, which was founded, was, what is it? You can type it. You can type it in your chat. I will see there in the chat. What is it? Okay, fine. It is called a Simula, and it was object oriented, which was found in way back. That is a history, and then after that there was Smalltalk, and after that C++, and Java, Python, .NET, everything came up. Okay, so all these object oriented programming have something in common. That is what we are going to see now. Okay. So all these object-oriented programming languages have something which is called as a class. A class is basically is a template to create an object. Okay, or you can say it is a framework, template. It is a blueprint. There is a lot of terms. Okay, so you can say that a class is a template blueprint. Okay. So why this blueprint is created means the only objective of this creating a blueprint of a blueprint is to create object, the class. The class is to create objects. So once I create an object called as, say for instance, the usual example which we say it in the classroom is you create a class for a student, create a class for an employee. Okay. So we will create putting attributes and methods and properties and everything inside a class using the any one of those programming languages, and we will put all those things inside the class, and we create what? We create objects. We create objects using the class. So when we see what we see, we cannot see the class. Okay, class is no more. Once we created a class will not be it doesn't take any memory space. Class doesn't take any memory space. Only objects takes memory space. Okay, memory means I mean the RAM memory. RAM is the main memory. Okay, so in main memory we create student objects, okay, using class. Okay, so usual question is how many objects we can create. See, how many students are you seeing in the class? How many employees you are seeing when you go to a factory? We see n number of students, n number of employees, right? So that number of employees and students we can create using the class, simple class. Okay, simple class. So these, now what is happening is the class is now into real-time environment. Okay, we are not seeing a class, whereas we are seeing a real student, real employee having the attributes that are specified inside a class. Attributes, I will come to that point later on. So I hope this is clear. Only with this clear, when I see thumbs up, I can proceed. Very good, very good, very good. Okay, fine. So okay, so once we create object, we call the object is something called as instance of a class. Okay, so we will not create single instance because we are not seeing single student, we are not seeing single employee, we are seeing n number of employees, n number of students. Okay, so these class enables us to create multiple objects. Okay, and they all have some common behavior which is there, which is represented inside the class. Okay, what is the common behavior? They will all have name, they will all have a study in a course, they will be enrolled for the exams, they will be doing they will be getting a pass mark or fail mark. Okay, so I like to here classify the attributes of the class. There are only two attributes of the class. One is, you make a note of it. If you have paper and pen, you can make a note of it. Okay. One is a data member of a class. The other one is the method of a class. There are various other names for method. Method is called as functions, methods, member functions. Everything is called the same, very similar. Where various programming language uses different terms. That's it. Okay, you need not worry about that. Okay, so that is a instance of a class, that is object. Okay, and all these objects represent similar behavior. Similar behavior, I mean, they all will have a name. They will all have enrolled for a course. They will all get a result, and this result will be either pass, fail, or grade. If you say that you evaluate a student using a grade, then that student might be getting a pass mark or a fail mark. Okay, how do we determine that? Based on the mark obtained by that student in that course. And you can all see one student passes, other student fails, isn't it? You will we all see. Okay, but I said something like they're all having some common behavior. Yes, common behavior is name and other things, but method is something, it is called as a behavior. Method is behavior. This method acts upon the data member and it reflects in the individual instance of the class, that is the object. Individual instance is objects, and each and every object is different because each and every student secure different marks. You agree, right? You all agree, right? You all agree? Very good. Very good, very good, very good. Okay. Okay. So So these students get either pass or fail, and this is one example of a method. And there are many examples you can give. You can say display the mark sheet of a student, display the or get the inputs for the student. Like inputs means getting the name, inputting the name, course and everything. For that you can write a method, and displaying the data you can write a method, and to display the result you can write a method. Or say, for instance, if there is some co-curricular activity like sports, okay, extracurricular activity, if a student does very well in cricket, okay, then that student will have additional attribute, additional behavior. That is a method. Okay, you have to when you create the blueprint, it has to be, see, these blueprint is all created using the software requirement specification. Okay, or breaking down that software requirement specification, we will say something called as abstraction. Okay, abstraction, we will come to that point later. Okay, but I hope this is clear. Okay, software requirement specification is called as SRS. That is a software engineering term, and that is completely we are not going there because that is a vast area. We are not going to go into software engineering because that motive is not that. Okay, so till now we have just created the class alone. Okay, we have just created the class. Okay, so when we create a class, what we see is we encapsulate what? We encapsulate the data members, the data members and the methods inside one unit called as class. And that is, or see, when you see a capsule, what is it inside a capsule? Capsule means in a medical shop you go and buy medicines, right? And the medicines might be tablets or capsules, and these capsules will have something inside. Okay, and that is what is inside, means the medicine will be inside. Outside is just a cover. Okay, and inside the capsule you have medicine. Like that, inside a class we have data members and methods. Okay, so that is encapsulation. So encapsulation is nothing but creating a class. That is called as encapsulation. Okay, moving on to the next topic. Next thing is instance creating. Okay, why to create a class? We all know why to create a class, because without creating a class you cannot create a object. Okay, first thing is you have to create a class. And what is a constructor and destructor? Constructor is a special method used to create a object of the class. Automatically create the object of the class is constructor. Okay, once you create a object using the new keyword. New keyword is the keyword used to create the class in most of the programming language. New, N-E-W, new keyword. Okay, that is the keyword for creating a class. And once you create a class, if at all there is a constructor created for the class, then immediately the first method will be called. Once immediately after the creation of the object in the memory, need not invoke any methods. Immediately the constructor will be called. Okay, I don't want to go into the practical examples because we don't have enough time. Okay, and destructor is something which is automatically done in many of the programming language. Automatically frees the memory. Okay, destructor frees the memory. The unused object that are residing in the memory will be cleared using the destructor. Okay, and that is destructors. Okay, and examples of OOPS languages, we all know there is many languages for OOPS. We have Java, Python, C++, .NET, and blah blah blah. Okay, we have many languages for the implementing object-oriented concept. Okay, so till this you're all clear, right? This slide, the introduction is clear, right? Clear. Okay. Next, see, next is something called as polymorphism. Okay, polymorphism. Abstraction. I will touch abstraction later. Poly means what? Poly means many. Okay. That is a Greek term. Poly means many. Morphism means forms. Many forms is called as polymorphism. A single object having many forms. For example, the usual example that I give in the class is, see, I myself take myself as an example of a object. Okay, I am a parent for my son, and I am a son for my father, or for my parents. Okay, I'm a son for my parents. So am I doing different role in different times? Am I doing a different role at different times? Yes or no? Yes, right? Thumbs up, thumbs up. Yes. Okay. I'm doing a different role at different times. So I'm a see, this is all real-time example. Okay, that is how real-world entities are created. That is how real-world entities like you and me are doing it. Okay, so the same thing was implemented in object-oriented programming. So polymorphism is many forms. Okay, so I myself is in many forms, and once my son gets married, I will be a grandfather. He is not yet married. Okay, so polymorphism is the ability of object belonging to different class to be treated as object of some of common superclass or interface. Okay, so I don't want to read it. I want to explain it. Okay, you read it. Okay, and inheritance and all these things. And the two major examples of polymorphism is method overriding, method overloading. Method overriding is done in inheritance, and method overloading is done inside the class. Inside inheritance is more, if you are writing more than one class, is that then means you are going to have inheritance. Okay, one class can inherit from the other class. Like I inherit most of my properties from my parents. My DNA is from my parents. Okay, and my son is inherited from me, and he will have DNA representing me and my father, that is his grandfather. Okay, so grandfather and mother. Okay, sorry for that. Mother is also a very important entity. So both of them will be those characteristics will be there with the son entity. Okay, son means son, not sun. Son. Okay, son or daughter. Okay, so that here we can see clearly, we can see inheritance, because I inherit from my parents. Parents are superclass. I'm a subclass, and my son is another subclass of my of me. So I'm having one superclass and one subclass. Okay, and yeah, is that clear? So inheritance is okay. I'm skipping. I'm just skipping from polymorphism and to inheritance, because when we want to see overriding, then I have to explain inheritance. Okay. So first, let me. Okay, inheritance. I didn't put any slide because I used to talk. Okay. Right. Okay. Okay. We stop with that, and I will continue with this one. Method overloading is creating more than one form of the same method, which is having different number of attributes, that is parameters, but different number of parameters. You make a note of it. Method overriding loading is done within the same class, not in a different class, whereas method overriding is done in two different classes. Okay, if you are creating the same method, everything is same. Okay, everything is the same. The method, the name of the method, the return type, the number of attributes, everything is the same. Attributes or parameters. Parameters are the one which you pass it within the brackets. Okay, you can see void my method int a, int b. Okay, int a and b are parameters. My method is the name of the method, and if I create two methods, with the same name, but only thing is my method will be, another form of my method will be no parameter method, and another form of my method will be 3-parameter method. Okay, if I'm doing like that inside a same class, that is called as method overloading. Rather, when I write 2 different forms of the same method in 2 different classes which are inheriting from other, okay, a subclass is inheriting from another class, and you can find a method which is both in the superclass and the subclass, but very similar method, but the implementation might be different. Okay, the subclass you might have got some 10 lines of code, in the superclass you might have got 5 lines of code. You have added some code in the subclass. Usually we do it in inheritance. What we do, we will inherit something from our parents, and then we add our own attribute, okay, properties. Because my father is not a teacher, he is an engineer, and I am a teacher and also an engineer, okay, because I'm teaching software engineering, okay. So so I add some more things. He doesn't know to teach, I know to teach, okay. So that I take my own example so that it will be easier for you to understand. It applies for you also as well, okay. It applies for you as well. So I think overriding is done in 2 different classes, that is inheritance. And there are many different types of inheritance: single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, hybrid inheritance. Okay, there are a lot of so when I say father, son, grandson, then that is multi-level inheritance. Okay, okay. And when I say father, daughter and son, okay, both are inheriting from same parent, okay, but daughter is a lady and son is a gents, okay. So what is this type of inheritance? Is it multi-level or multiple or what, or any other hybrid or any other type of inheritance? You can type it, guys. You can type it in the chat. Are you allowed to type? You are allowed to type. I like to see you typing in the chat. Why are you not typing it? Okay, fine. You type it later on. Okay. What is my question is, that one is a question for you. You answer it. You research it. Okay. So I don't want to talk about all the types of inheritance. Rather, I will go to the next topic. Next slide. So there are 4 principles. This is a pictorial representation of the same object-oriented. I just put it from the LinkedIn. Okay, I'm very active in LinkedIn, so you can find me in LinkedIn. Abstraction and what is abstraction? See, abstraction is simple, complex. This is very complex, right? It is very complex. Okay. See, abstraction is when you do software engineering, what we do is we start our engineering activity. First thing is, before even writing the class, what we do is paper and pen work. We do it. Paper and pen means you have to create a class for a student. Immediately, you have to list out all the attributes of the student. Okay. You say name, grade, class, age, everything. Okay. And from that abstraction activity, what you do is you differentiate which is a data member and which is a method. You categorize it. Okay. You categorize it. Okay. So some might be data members and some might be methods. And in object-oriented programming, more emphasis is given to data members. Data. Okay. Data is the more crucial one. Whereas in functional programming, in C, more importance is given to methods. But here in object-oriented programming, more importance is given to only data, not to methods. Data is the crucial part. And that is why data science is there, big data is there, and lot of jargons are there. That is all around data. Data is the fuel for next 20-30 years. Okay. because we every day we produce trillions, millions of data. We accumulate Google, everything is handling only data, and the data is money. Okay, data is money. You might have seen earlier Facebook, they sold the Facebook users data, or somebody stole it from the Facebook and they made money out of it. Okay, that is all because data is money. Money means if you go and put fuel, you have to give money, right? So the fuel is costly. Okay, yeah, right. So data is also expensive. That is why more emphasis is given to data. Are you getting me? You are getting me, right? Okay, fine. Okay. So here in this abstraction activity, what we see is you see a laptop, simple interface, screen, keyboard, touchpad is all simple. Complex is processor, RAM, hard disk. One thing common about everything is they're all parts of laptop. Okay, they're all parts of laptop, and some might be simple, some might be complex. Okay, so what we do is we just list out all the members of class, and then later on we can say which is simple, which is complex, which is in between, like that we can categorize it. So some things we can neglect it, some things which are very, very important we can include it, because in case of computer everything is important, laptop everything is important. Without processor nothing will work, without RAM nothing will work. Okay, but without external mouse I can work on my laptop. Yes or no? External mouse, is it more important? External mouse, yes or no? Internally there is a mouse. Okay, internally there is a touchpad. So where no, very good. So abstraction is you list out everything which is related to that object, and then later on you decide which is important, and that pick only that and then work on that. That is abstraction. Okay, is that clear? Okay, I have completed abstraction, encapsulation, polymorphism, inheritance. So I'm going to move on. Okay, so we have completed this. Encapsulation, another example is of encapsulation is pictorial representation of example is you see a house, it is called as a house. Only when people are inside it is called as a home. Unless people are inside, it is just called as a house. Okay, so house will be having doors, exterior, these are all exterior. Okay, exterior, and some might be interior. We cannot see it. Like when we have a capsule, we cannot see the medicine which is inside. Okay, but we can see outside. The color of the capsule might be green and red, that we can see. That is which is similar to door and exterior everything. Okay, but what is inside, unless you open the door and go inside, you cannot see it. So inside there might be rooms and some belongings which might be there for the owner of the house. Okay, so this is encapsulation example. Okay, object-oriented programming forms the backbone. So that is the introduction part of the object-oriented programming. I think I have covered most of the important definitions. If at all I have missed it, it is not by plan, but it is something like out of the time constraint I might have missed it. Okay, so object-oriented programming forms the backbone of the scalable and multi-maintainable software development. It is the backbone. Okay, backbone means you all know how important is our backbone. Okay, without the backbone you cannot walk. Okay, so object-oriented programming, without object-oriented programming none of the softwares are scalable, maintainable. Okay, only because of object-oriented programming most of the softwares are scalable. Okay, you take any software, even the browser, even the Office, Microsoft Office, all are in somewhere the core part will be object-oriented programming. The core part will be object-oriented programming. which actually promotes reusability, modularity, and encapsulation. Okay. Abstraction, abstraction involves hiding the complex implementation details behind behind a simple interface. So when we see abstraction, when we see the house, we cannot see what is inside the house. The complexity is inside, but outside, the color, the door, the windows, roof, and all, you can see. Okay. What is inside? Unless you go inside, you cannot see what is inside. Okay. So you read, I have already explained inheritance, encapsulation, polymorphism. The key benefits of abstraction are these: easy maintenance, user-friendly interface, consistent abstraction, enhances security. Okay, sensitive data is protected. Okay, how we protect sensitive data? Using what? Access specifiers. Using access specifiers. Okay, we protect data, enhance like sensitive data, or complex code is concealed, hidden complex code. These are all done using private, public, protected default keywords. Okay, user interfaces, user-friendly interfaces is also one of the key benefit of abstraction. High-level interactions are there, easily maintainable, and all those stuff. These are all benefits of abstraction. Okay. So building a data pipeline using object-oriented programming. Okay. Why we build data pipeline? Because for scalability and maintainability, we build the data pipeline. Okay. Building data pipeline using design the data models. So data models, we have to design it. Okay. Because as I told you already, data is the most important part in the software, in object-oriented programming. So designing the data models is also very important. So you have to plan very carefully how to design, because you in database you have schema, you have a lot of data models. You have DOM is document object model, and you have data represented different terms are there. Okay. And nowadays you have MongoDB, which is used for unstructured database development. Okay. Yeah, excuse me. Yeah. So before diving into the code, so I don't want to read it. You read it and understand it. Anyway, the PPT will be shared. Designing data model is important. So one of the for scalability and maintainability, you have to do these activity. Okay, building the data pipeline using object-oriented programming. So data models is the first step. Second step is testing and debugging. Okay, and that is very important, because without testing, if you release your software, it won't be working according to your specification. Okay, according to the specification, if you want to work, means you have to test the software across the SRS, software requirement specification. Okay, whether all the specifications are implemented or not, whether output is coming as per the requirement. And there is test engineers, software test engineers are there nowadays. In full stack, we don't have test engineers, whereas an engineer is a full stack engineer, means he has to do all the activities starting from analysis, design, coding, testing, implementing, maintaining, support. Everything has to be done by the full stack engineer. One single guy has to do everything. Okay, that is why full stack engineers are well paid in the industry. Okay, and you don't get experienced full stack engineers. Okay. Okay, testing and debugging, and it is a separate field. Testing is a separate field, and there are a lot of testing: manual testing, automated testing, unit testing, black box testing, white box testing. There is a lot of testing, and I can speak about testing for 1 hour. Okay, but the time will go. Okay. So, and when you create testing, you have to create test cases, and different things are there in test case, test fixtures, assertions, runners. I don't want to go into these things, but I just want to put it because when you read this PPT, you will do more research and gain knowledge. Okay. You see, guys, remember, a day without learning is a day wasted. Okay. Every day you have to learn something. Okay. So scalability and maintainability. So once we do these activity, unit testing, more data models, that building data models, and the testing, debugging, then we are into scalable and maintainable software. Okay, so what is the definition for scalable? As the data volume grows, you might need to scale your pipeline components independently. Independently means each and every components which are there in the modules which are there in the software has to be tested independently. That is unit testing. And also after linking every modules, you have to test it once again. Okay, and there is a lot of activity for lot of test cases, and lot of things are there. Lot of different types of testing is there. Okay. Maintenance, once the software is delivered, maintenance is support. You might have seen somewhere like the term is called as annual monthly fee. They will say something like that. I forgot the term, annual subscription or something. Okay. So that is for maintaining the software. So once the software is delivered to the customer, then also the vendor, the company which created the software will get some revenue out of it, because they have to maintain the software, maintain the data, back up the data, and restore the data. Sometimes problems might arise and they have to restore it. Sometimes the system might crash. Sometimes there might be some hazards like earthquake. Recently in Nepal, there was an earthquake. So in those cases, the software has to be installed and structured. Okay. So that is maintenance. So this is conclusion of object-oriented programming for scalable data pipeline. This is one of our main agenda. So learn how object-oriented programming forms the backbone of scalable and maintainable software development. That is only using uh, testing, debugging, and what else? Testing, debugging. Type it. Designing data. Very good. Very good. And then another one. Design and maintenance. Very good. Designing data models. Okay. Testing, debugging, unit testing. Okay. And that is how we build scalable and maintainable software. Raise your hands. I will, you can raise your hands later on. I will, there is a question answer session. So this is all about conclusion of data object-oriented program for scalable and data pipeline. I hope that is clear. The second agenda is completed. Let us go to the third agenda. How to choose a suitable programming language. See, since we have got a lot of programming languages, we might be confused, right? There is Java, Python, C++, .NET is also there. Okay, each one of these languages has their own pros and cons. Okay, in Java, is multiple inheritance possible or not? Yes or no? In Java 8, is it possible? Java 8. Before Java 8, is it possible? After Java 8, is it possible? You have to check that. Okay. No, sir. Before. After? Okay. You will check it. Possible, sir. Very good. Very good. Very good. Okay, fine. Popular object-oriented programming languages: Java, Python, C++. Okay. So we are just having only taken three, but apart from this three, there is many other languages like .NET is also C#. .NET is also object-oriented. JavaScript is object-oriented. JavaScript is object-oriented. Earlier it was object-based programming language. Now it is object-oriented programming language. Okay. So Java, as we all know, Java, write once, run anywhere. Wora is write once, run anywhere. WORA. Okay. And you can build different types of applications, starting from desktop application, Android application, web application, enterprise application. Java is everywhere. Okay, Java is everywhere. Even my laptop, my phones, everything, there will be Java. Okay, that is why Java is most popular. But when we see the next popular one is Python. Python is also as popular as Java because of data science and other MI and AI. Python has reached top of Java. Okay, Python is now very simple than Java and also very powerful than Java, because Java has some limitations. It cannot be used for, or maybe certain level it can be used for AI and ML, but Python is more scalable and more fit to be used in AI and machine learning, artificial intelligence and machine learning. Python is top. Okay, not Java. C++ we all know. Okay, it is also a object-oriented programming language, and multiple inheritance is possible in C++. Multiple inheritance is possible in C++. Yes or no? Yes, very good, very good, very good. Okay, multiple inheritance is possible in C++. C is a high-level language, is the functional language, procedural language, but C is a C++ is a super set of C. Whatever you can see in C language, you can also do it in C++. Okay. Apart from that, C++ is object-oriented, so it is more powerful than C. So Python is also powerful. Okay. So I have compared all those languages and then aspect everything I done. This is a class bicycle. Object is two types of bicycles are there. Either might be a race cycle, or it might be a family cycle, or old version of cycle. Okay, these are all object. Okay, but both are called as cycle. Okay, both have same properties: color, brand. Method is gear count. Okay, if at all a cycle has a gear, it can you can have how many, you can have a method called as gear count. And once the Bianchi cycle has 2 gears, means Oriba cycle will have 3 gear or 5 gear. Okay, and the color is different. So 2 different object which is created by one class. Okay, like 3 students or 10, 100,000 million students from one single student class, the same thing. So attributes, methods, properties, purpose, everything is there. Class, you refer this. I don't want to. I have already spoke about these things. What are the common mistakes in object-oriented programming? Yeah, common mistakes in object-oriented programming. Violating encapsulation is a very common mistake. Read it. Okay, the links are given here. All the links. I took everything from these links only. Okay, you refer it, and there is some YouTube videos also. You like, share, subscribe it. Okay. And common mistakes. Okay, solid principle. Okay, violating encapsulation is the most common mistake. When you violate it, nothing can be done. Okay, See, this violation is something like not following proper encapsulation steps, like not having using, say, when you create a class, the data members should be created as declared as private, okay, and only the method should be private, sorry, public, okay, and you should have getters and setters that is set, that is mutators and accessor methods for the data members can be automatically created using the IDEA J IDE, okay. I use IDEA J IDE for Java full stack, okay. So, and then yeah, violating it, you should not violate it, you should carefully define it. Solid principles are design patterns. Design patterns are patterns for use for design. There are a lot of patterns. Refer this link. You will see what are the patterns are available. Okay, you will refer it. And if at all you have got any problem, you can mail me. You get the mail ID from the CSI. Misusing patterns is also a common mistake. Refer it. The thing is given. The link is given. Go and refer it. Neglecting the testing is another common mistake. So you should not neglect testing. It is very, very important to test the software before it is released. Overuse of inheritance. Yes, overuse of inheritance means multi-level inheritance. Say you have many levels of inheritance, then it is complicated. Okay, it is very complicated. Okay, so stop doing you do multi-level inheritance, but the number of levels you reduce it. Try any other means of implementing it. Okay, don't overuse inheritance. Okay, applying concepts in case studies. Applying OOPS concept in case study is like something like once you do everything in your projects, then you are applying it. Okay, you are applying really you are applying it. You can apply it in any area. Every area has object oriented programming. All areas are having it. Okay, so, and that's it all about the session. I have completed the session. These are the references. You can go and refer it. I have told, I have requested the CSI to share some materials. I have got some 4 documents along with this 5. Okay, so 5 documents will be shared to you by the CSI, and I thank the CSI for this wonderful opportunity, wonderful evening, and let us open up for question answers. Thank you, guys.
Sir, thank you very much, sir. At the time of registration, we have asked the participants to record their questions. Now I'm going to project the questions for your reference. You can go through and give your response. Sir, now I am going to present. Dear participants, this is the Q&A session. As informed just now, the questions that are collected at the time of registration are getting projected here. It's a consolidated list, and our guest speaker will be responding back to the queries. Sir, now we can. Sir, the questions are projected for your reference.
Okay, let them ask the question. They are not allowed to speak.
Yes, sir. Here we have a consolidated list. And apart from this, if any open questions are there, the participants will be
These
asked.
questions, I can see. Let them open up.
Sure, sir. Thank you.
Yeah, it's the floor is yours. You can open up and you
Dear
can
participants,
ask.
the floor is yours. You can either unmute your mic and ask the questions, or you can type it in the chat window.
See, don't be afraid to ask questions. Unless you ask questions, you cannot learn. Please ask questions. I'm not that rude. I'm very kind.
In the very beginning of the session, few participants raised your hands. Now it's your time. You can ask your questions.
Do we have the questions that have been sent by participants?
Yes.
Sir, we do have. I'm going to present it.
See, low-level design is something which is from design patterns. Okay, and design patterns, you have to start from introduction to design patterns, and there are a lot of design patterns. And
புரிஞ்சது அது 3 மார்க் ஸ்டேட்மெண்ட் தானே அது 3 மார்க் ஸ்டேட்மெண்ட் 4 மார்க் ஸ்டேட்மெண்ட்
Mr. Bhuminath, the
Bhuminath,
noise
could you please mute Bhuminath, or maybe we can drop him?
சரி ஓகே ஓகே இல்லைன்னா நான் இருக்கிறத எடுத்து அனுப்பிவிடுறேன் சரி ஓகே
Please mute Bhuminath or drop him, please.
Okay, sir. I will answer the questions. You can mute everybody. I will answer the questions. See, how can coding be used in business? Because business is nothing but the software requirements basically. Once you understand the client and create a SRS, then you are into software engineering. Okay, you are into software engineering. Okay. So sorry for that. So that is how can coding be used in business means, yes, in all the business, the enterprise businesses uses coding. Okay. So how is OOPS used in real life means how I told it. I already explained it. How like matches work in science? What is this question? How to increase skills? How to update myself? I have a gap of 9 years in IT. Whether this webinar will help me to update me and help to find a job, you have to say the answer for that yourself. I don't know whether it is up to the individual skill. I have doubt about the specific in OOPS and encapsulation. I hope I have cleared it. This design is easy to or difficult. It is up to you. Okay, if you think it is easy, it is easy. If it is not, it is not. Okay. Language that will be easy for beginners to build a software. Language easy. Okay, Python is the language. Easy. Okay. Will be able to develop the coding only if we learn computer languages completely? Yes. Not completely. At least 10% if you learn, then you can do coding. Okay, not complete. Nobody knows completely. Only going to the industry you can learn completely, or even 50% you can learn. See, I don't have no completely any even one programming language I doesn't know completely. I know everything bits and pieces. Okay, I don't know. I did not get even one international certification like Java 8. I didn't get, but I'm a Google certified educator level 1. Okay. More than communication and coding knowledge and aptitude, logical reasoning, what are the qualities that are crack the interview? Okay, communication is very, very important. More than communication. You told more than communication. Okay. More than communication is your confidence level. They will test your confidence level. You have to be bold. You have to, even if it doesn't know the answer, then what you have to do is, in the face-to-face interview, you have to say, you have to be bold, and you have to show your confidence that give me a job, then I will prove it. Otherwise you drop me out of the job. You challenge the panel members, then you will surely get the job. I challenge them. I will challenge them. Okay. Step to crack the interview as a fresher. Yeah, the previous question is there is an answer to explain about how to start studying a language from the scratch. Okay, you have to start from data types, history, everything you have to start. Okay. Coding constructs, keywords, and then symbols. Okay. What is that? Relational operators, statements, everything you have to study. Okay. That is what is importance of object oriented in real life. I told which language is most preferred, Python or C++ or Java? Python. Which should I concentrate? Either on DSA or mini projects, both DSA and mini project. Without DSA, you cannot do a mini project. Okay. OOPS concept is Java. I have scope in future. Yes, surely it has. Will this cover IDV? No, I answered.
Sir, these are the questions that were asked by the participants at the time of registration. And apart from that, only one question was there, which was there in the previous slide. One participant has asked about it.
What is the question, sir?
Sir, he asked about low-level design.
Low-level design.
Saranya Guruvayurappan. She asked about tips on low-level design.
Guruvayurappan, go. The link is there in the PPT. Go and read it.
Is it?
Yes, sir.
Is it
Yes,
audible?
sir. Now we are able to hear you.
Yes, sir. Good evening to one and all present in this virtual gathering. On behalf of the Computer Society of India, Coimbatore chapter, I am here to propose the vote of thanks. Today's webinar on object-oriented programming simplified, a beginner's guide to software design, presented by Mr. Murugesh, a technical trainer by profession, was explained in an efficient and effective manner. As participants, we were able to understand the essential parts of OOPS, its scalability in software design and development, and how to choose the programming languages. Mr. Murugesh would have taken his valuable time in preparing for this webinar, for which we appreciate and show our gratitude. Many thanks to you, Mr. Murugesh, for accepting our invitation and delivering the talk. My gratitude goes to the 100+ virtual participants who took time in attending this webinar organized by CSI Coimbatore. As always, we expect your earnest participation in all our future endeavors to be organized by CSI. My thanks to our office admin staff, Mr. Durvesh, for ordering his question, our chairman, Mr. Saravana Kumar, for his welcome address and special initiatives of CSI, Dr. Maharasan, MC member, for his guest introduction and ceremonizing the event. Once again, I thank you all indeed and best wishes for taking away the key points from this webinar. Computer Society of India Coimbatore chapter wishes a happy Pongal 2025 to all the participants. Thank you and see you all in our next event. Good night.
Sir, thank you very much, sir. Dear participants, thanks for your active support. And please submit your feedback. And those who are submitted can leave the meeting. And as informed, the link for feedback will be active for another 45 minutes. Thank you.
Thank you all. Thank you.
Thank you very much, participants. From the Coimbatore chapter of Computer Society of India, we all wish you a happy Pongal.